Okay, so we begin with circles. Now, one more thing to add is that this paper does get progressively harder, or at least I tried to make it that way anyway, so the questions at the end should be harder than the questions at the beginning. Okay, let's start then with the classic question. So I picked this one here because it comes up so frequently, and that's just find the coordinates and radius of a circle, which is not in completed the square form. So let's give it in completed the square form. I've got 8x here, so we just half that to get 4. So it's x plus 4 squared, and then whenever you complete the square, you always take away that half b term squared. And then for the y's, in this case we have minus 4, so I half that to make minus 2. So I get y minus 2 squared, and then I always take away, again, whatever that value is squared, and that equals 0. Okay, let's tidy this up. So I'll bring my two completed square brackets together. And what have I got here? I've got minus 16, and that will be minus 4. Bring those to the other side, that makes positive 20. Okay, great. So now this tells me exactly what the centre is. It's at minus 4, 2. It's just whatever solves these brackets when I set them equal to 0. So x equals minus 4 solves that one, and xy equals 2 solves the other one. Okay, and the radius, well, the formula is always equal to r squared. So the radius squared is 20, so the radius is the square root of 20, which is the same as 2 root 5. Beautiful. Okay, that's a classic question, and that is done. Give me those marks. Yes, please. Next, we've got a point P on the circle, and we've got a tangent to the circle at P. Find the coordinates of P. Right, so if I was to just give this a quick sketch, you've got a circle, and you've got a tangent, and it's telling me that this is the point P. So this is great, actually, because, well, this is the equation of the circle, and this is the equation of the tangent. So to find where they intersect, that must be the point P. So we just have to solve a simultaneous equation. Now what I'm going to do is I'm going to rearrange this to make x the subject, and that way I can substitute it directly into this equation at the top. I'm gonna choose the one they've given me rather than the completed square one, just in case I've made a mistake early on. Subbing into the equation they give you is just more of a safer bet in an exam. So the first thing I do is I square x, and then I add y squared, and then I add 8 lots of x, and then I subtract 4y, and that's equal to 0. Okay, let's expand. Double quick time. Minus 2y times y itself will give you 4y squared. You'll get a 20y and another 20y to make 40y, and we'll get 100. Okay, we've got a y squared there. We'll get minus 16y minus 80 minus 4y equals 0. Collect like terms. We've got 5y squared. How many y's have we got? It looks like to me plus 20. A numerical term looks like a constant term, should I say, plus 20, and that's equal to 0. Divide through by 5 just because you can. Lovely. So we get y factorised, should I say. That is a perfect square. Lovely. So y equals minus 2 is the y coordinate. And then the x-coordinate, well, let's just sub it into this formula here, because it must be on the line, so it must satisfy the line equation. So minus 2 minus 10 is minus 6. So P has the coordinates minus 6 minus 2. Lovely. Job done. Okay, next question is vectors. Vectors does come up a lot. And again, people find it tricky. We got 2, 3, 4 position vectors. Lucky us. and we know that ABCD is a parallelogram. Find the position vector of point D. Okay, well, for 2 marks, that does seem rather a lot of work just for 2 marks. But let's imagine what a parallelogram looks like. So it would look something like this. And the key thing to note is that when it says it in this order, A, B, C, D, it means that we must label the parallelogram in that order. So just going around it, it has to be in that order. Okay, so let's find the vector B to C. I reckon that's going to be really helpful. So B to C is OC minus OB, which in this case is, I like to do mine in columns like this. I find I make less mistakes in columns than I do with I's and J's. 4, 3 and 3. Hopefully I don't make a mistake now. Minus 2, 7 and 6. Okay, so now how do I get to point D? Well, what I can do is I can start at the origin, as always, and I can go to point A. So that would be the vector O to A. And then if I added on B to C, well, that will get me to point D, because B to C is parallel and identical in terms of a vector as A to D. So I can say that if I want to go from O to D, then I just need to go to A and then add on BC. So that is going to be 1, 7 minus 2 plus minus 2, 7, 6, which is going to give me minus 1, 14 and 4. And then finally, I must give my answer in the form that the question has stated it in. So I must write it as minus I plus 14j plus 4k. Perfect. The vector AX has the same direction as AB. Okay. Given that AX's magnitude is 10 root 2, find the position vector of AX. Okay, so of X, sorry. So let's imagine then that X is somewhere over here, and we know that it has the same direction as AB, so A to X is on that same path, so that makes sense. It just has a different magnitude. Okay, so what we can do is, first off, we can find the magnitude of A to B. And that will be, well, actually, first off, we'd actually have to find A to B. So let's find A to B first. So A to B is OB minus OA. Which is 4, 3, 3 minus 1, 7 minus 2, which is 3 minus 4 and double negative, so 5. Okay, so the magnitude of AB is the square root of the square of 3 plus the square of minus 4 plus the square of 5. And I think that is actually, is that going to be a whole number? Actually, I don't know. Let's just figure it out. Okay, it's 5 root 2. Lovely. 5 root 2. So that tells us that AX is just essentially twice as big as A to B. Okay, so how do I get to O to X? which is the position vector, well, I need to go to A first and then add on two lots of AB because AX is two lots of AB. Okay, so that should be relatively straightforward. We start with A, which was 1, 7, minus 2. And then we add on two lots of AB, which was 3, minus 4, 5. So this gives me 1 plus 6 is 7. 7 minus 8 is minus 1. And minus 2 plus 10 is 8. And once again, I'm just going to give it in the same form that they give theirs in, I's, J's and K's. And we're done. Question number 3, exponential modelling. The growth of a weed on the surface of a pond is being studied. How exciting. The surface area of the pond covered by the weed, a metre squared, is modelled by the equation blah, where p is a positive constant and t is the number of days after the start study. Always highlight the fact that it's measured in days, because I know that will mess me up if I don't know that. Given that 30 centimetres of the surface of the pond was covered by the weed at the start of the study, great, and 50% was covered after t days after the start of study, show that p is equal to 2.4. Okay, so I mean the first instance, we must just be subbing in the first part, which is when t equals 0, because the second bit of information is not going to give us much help just yet. So it says that the area is 30, so I'll say 30 is equal to 80 p, e to the 0, because t is 0, over p, again, e to the 0 plus 4. Let's tidy this up because e to the 0 is 1, so it's 80p over p plus 4. Multiply through by 3 plus, p plus 4 gives me this. Subtract 30p. Divide through by 50, and we get 12 over 5 is equal to p. So p is equal to 2.4. Perfect. Okay, part B. Find the value of t, giving your answer to one decimal place. Okay, I can do that. Let's move this away. And let's now rewrite this formula. So I know that 50, using the second bit of information, is going to equal 80. P is 2.4. E to the 0.15 t all over 2.4 e to the 0.15 t plus 4. Okay, so I would then multiply it up. Let's just do a few quick calculations. So 50 times by 2.4 is 120. So I get 120 e to the 0.15 t plus 4 times 50 is 200. And that's equal to 80 times 2.4, which is 192 e to the 0.15 t. Okay, perfect. So I've just moved the denominator to the other side, times it by 50, and then I've just expanded that bracket at the top there. Okay, so now we can subtract 120 e to the 0.15 t, and that leaves me with 72 e to the 0.15 t on that side. Divide through, so 200 divided by 72 is 25 over 9. And that's equal to e to the 0.152t. And then we need to ln both sides, and that will cancel the e to the power of, and it will just bring that power down. using log rules. And then what we're left to do is just divide. So we divide through by this, and this is what's going to go into my calculator. And I won't bore you typing it in, I'll just pause it. Okay, and I have got 6.8 to 1 decimal place, and to get full marks we have to write days. Okay, you've got to give the units there. And there we go, we're done. Let's move on. Okay, question number 10. This is a proof question, and again I've seen lots of students get this one wrong, so that's why I've put it in there. And it's just a standard skill also that we need to know, that in order to prove something, most of the time it's a good idea to show for evens and for odds, because if you show for evens and odds, then that's all the numbers. Happy days. Okay, so what I'll do is I'll say let n equal 2k, which shows that that's an even number, and then what we'll do is we'll say that then n squared plus 2 is equal to 2k squared plus 2, which is equal to 4k squared plus 2. And we can say this is equal to 4 lots of k squared plus 2. And we can say as 4k squared is a multiple of 4, then 4k squared plus 2 is not a multiple of 4. Okay, right, and then what we do is we say let n equal 2k plus 1, which is an odd number. Then n squared plus 2 is equal to 2k plus 1 all squared plus 2, which is equal to 2k plus 1 times 2k plus 1 plus 2. So that's 4k squared plus 2k and 2k makes 4k, plus 1 times 1 is 1, plus 2. So this is 4k squared plus 4k plus 3. So we can factorize out the 4 from these two terms here, like that. And then we can say as 4k squared plus 4k is a multiple of 4, 4k squared plus 4k plus 3 is not a multiple of 4. And then, this is where lots of students forget to write the conclusory statement. We can say we have proved n squared plus 2 is not divisible by 4 for all even numbers and for all odd numbers. Therefore, it is true for all natural numbers. We must write that at the end if you are wanting to get the full marks, otherwise you miss out on a mark if you don't write that conclusory statement right there. Okay, feel like I've written an essay there, but I want to get all those marks, and I just want to make sure that the examiner does not penalise me at all. Given that x is a real number, the value of the modulus of 3x minus 20 is greater than or equal to the value of x minus 9. State giving a reason if the above statement is always true, sometimes true, or never true. Okay, so let's just write that down. So that would be the modulus of 3x minus 28 is greater than or equal to x minus 9. Okay, so I'm going to try x equals 1. And this gives me 3 minus 28 is minus 25, which is equal to 25, which is greater than or equal to x1 minus 9, which is minus 8. Okay, so that works for that. Now, is there a number where it doesn't work? Because all we need is just one number. And let's go for something like, well, when is this the smallest it could possibly be? And that's when x is equal to 28 over 3. So when x is 28 over 3, then the modulus part is 0, and this one is positive. So that doesn't work, because 3 lots of 28 over 3 minus 28 is not greater than or equal to 28 over 3 minus 9. Because this side, the left side is 0, and the right side is negative. So it doesn't work. So therefore, the answer is sometimes true. Wallop. Okay, next question is functions. And the reason why I've picked this question is because, I mean, just look at all the marks. 3, 7, 9, 12, 13 marks. Wow. Such a good topic in terms of marks. Okay, first one, find the inverse function. Okay, so what I need to do is I need to first set it equal to y. So y is equal to 3x minus 5 over x plus 1. Okay, now, because the inverse function is always a reflection in the line y equals x, because it swaps the input x for the output y, we need to swap over our x's and y's. So we say that x is equal to 3y minus 5 over y plus 1. We then need to multiply both sides by the denominator, and we're going to rearrange to make y the subject. So I'm going to multiply out the brackets. I'm then going to collect all the y's on the same side. So I'm going to do x plus 5 on this side by adding the 5 over, and I'm going to write 3y minus xy on that side. I'm then going to factorize out y, because then that will then allow me to divide through by 3 minus x. So I can write y is equal to x plus 5 over 3 minus x. And then to finish off, we must write it's the inverse function that is equal to x plus 5 over 3 minus x. And there we have it. That is part A done. Okay, going up. Show that the f of x is equal to x plus a, where a is an integer to be found. As I say, so composite function means I need to sub f into itself. Okay, So I've got f right here, so I can just start working like this. And I can say that f of x is equal to, I'm just going to write out f, but every time I get to an x, I'm going to write out f of x again. So like this. And then that's minus 5 all over x, which I need to write out as f of x. So that's 3x minus 5 over x plus 1, and that's plus 1. So hopefully you can see what I've done there. I've just written out f of x, which is this, but every time I've got to an x, I've actually substituted in f of x. So that's f of x going in to itself. Okay, so now we need to simplify this, and what I'm going to do is multiply the top by x plus 1 and the bottom by x plus 1. So this won't affect the function because you're timesing by essentially 1. But what that will do is the first term here, it will cancel the x plus 1 on the bottom. So I'm just left with 3 lots of 3x minus 5. This term here, that will include the x plus 1. I have to multiply by x plus 1 there. Okay, let's do the same for the bottom. Again, timesing by x plus 1 will cancel the denominator here, so that will just leave me with 3x minus 5. But I also have to times this 1 by x plus 1, which just gives me 1x plus 1. Okay, simplifying the top. Let's do this in one step. Save time. 9x and then minus 5x gives you 4x. Minus 15 minus 5 is minus 20. And then on the bottom I've got 4x, and I've got minus 5 plus 1 is minus 4. And then finally we can divide every term by 4 to get x minus 5 over x minus 1. Beautiful. Okay. It does say a is an integer to be found. I think I've done enough to show that a is 5 there, but I'll just write it down just in case. Oh no, minus 5, sorry, minus 5. Minus 5. Okay, that'll do. Okay, so it says that g is this function. Find the value of f of g. Okay, so that means that I need to substitute into g first. So g of 2 is going to be 2 squared. Let's just quickly show you what g is. It's that. So it's 2 squared minus 3 times 2, which is 4 minus 6, which is minus 2. And then that goes into f. So f of g of 2 is the same as f of, well, g of 2 is minus 2. So subbing into f, which is 3 times x minus 5 over x plus 1. So that's minus 6 minus 5, so that's minus 11. And that's minus 2 plus 1 is minus 1. So that just gives me 11. Okay, great. Find the range of g. Oh, this is great functions question. This covers literally everything you need to know for functions. The range of g, well, that's a quadratic. And it's a quadratic which has a domain between 0 and 5. So what, didn't mean to do that. But what we're going to do is we're going to sketch it essentially. It's the best thing to do. Okay, so let's just get some more space down here. Part D, it's x squared minus, sloppy, forgotten what it is already, minus 3x. And that is between 0 and 5. Okay, so just a quick sketch is going to be very helpful. So at 0, we know it's 0, so that's useful. And at 5, we know it's 25 minus 15, so it's 10. So that's also useful. Okay, we also know that it has a root where it equals 0, because we can factorize like this, which shows us that it must go through 3. So we've got the shape of the graph. We just need to now know the minimum point, because it's going to go like that. So what's this minimum point? There's a couple of ways of doing it. I could complete the square, I could differentiate, or I can notice that the minimum point will be halfway between the roots. So the minimum point is at x equals 1.5. So I can sub that in, so I get 1.5 squared minus 3 times 1.5. So that gives me 1.5 squared minus 3 lots of 1.5. And that's minus 2.25. So I know this point here is 1.5 and the y value is minus 2.25. So there we have it. The range of G goes from a low of minus 2.25, where it can equal that. Yes, it definitely can. G of x is the symbol that we have to put in between. You lose a mark if you put x, because it's not the domain, it's just the range. And that's up to 10 is the highest point. And that's that done. Okay, and explain why the function g does not have an inverse. Okay, so this is a kind of standard one that you say. G is not a 1-to-1 function, therefore it does not have an inverse. You could say that, well, that's it. It's just not a 1-to-1 function, therefore it doesn't have an inverse. Job done. Okay, binomial expansion. And it's just a straightforward one, so let's do it. So the first thing I would do is write this as 4 minus x to the power of a half. And in order for the binomial expansion to work, we need to make sure that the constant term is a 1. So I need to factorise out 4. But when I take any factor out of a bracket, I must also take out the power with it. So 4 to the half needs to come out. And that means I can that allows me to divide everything inside the bracket by 4. Okay, great. So 4 to the half is 2. So 2 goes outside. And now I can use my formula for the binomial, which is, if you don't know, 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, n minus 2, all over 3 factorial x cubed, and so on. So, in this instance, the x term is in fact x over 4, and the n term is the power, which is in fact a half. So we start with 1, so 1, and then nx will be a half times by negative x over 4. Oh, actually, I should have made that really clear. The x term is negative x over 4. Don't forget that. So I'm doing negative x over 4 times a half is negative x over 8. And then what we're doing is we are doing a half multiplied by n minus 1. So half minus 1 is minus a half. That's all over 2 factorial. And we're timesing our x, which is minus a half x over 4 squared. We're squaring it. That's all we need to go up to, because it only goes up to the x squared term. So I can close my bracket there. And I can then just simplify this up a bit before I expand out by 2. So this one's all good, but this one's a bit of a mess. So I'm going to just do it in my head. We've got one negative because that negative will be squared to make a positive. We've obviously got an x squared. and we're dividing by 2, we're dividing by 2 again, and we're dividing by 2 again, so that's 8 on the bottom, and then we're dividing by 4 and 4. So that was an 8, that was a 4, and that was another 4. So 1 over 128. Okay, and then let's finish this up by multiplying through by 2. So it's 2 minus x over 4 minus x squared over 64. Okay, lovely. Well, k is a rational constant to be found. So I will then just finish up by saying that k is equal to 1 over 64. Lovely. Negative. Careful. Okay, a student attempts to substitute x equals 1 into both sides of this equation to find an approximate value for root 3. Giving a reason if the expansion is valid for this value of x. Well, when is the expansion valid? We take whatever x value was, in this case it was minus x over 4, and we take the modulus of that, and we make sure that that needs to be less than 1. Okay, so the fact that there's a negative there really doesn't matter because the modulus sign will take care of that. And then we can multiply through by 4, both sides. Okay, so this tells me that x needs to be less than 4. So x equals 1 is good. X equals 1 is valid. And that is job done. Okay, next question, geometric sequences, and this question, you have to take a lot of care over it. A competitor is running a 20-kilometer race. She runs the first 4 kilometers at a steady pace of 9 minutes per kilometer. After the first 4, she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modelled to be 5% greater than the time she took to run the previous one. Okay. Show that her time to run the first 6 kilometers is estimated as this. So the first 6 kilometers, well, we know the first 4, she will be doing it in 6 minutes. So that's 24 minutes. And the next one will be 6 minutes multiplied by 1.05 because there's going to be a 5% increase in her time. So without getting too techie with this, I'm just going to work out them and add them up basically. And then the next one will be 6.3 times 1.05. So just times that by 1.05. Again, slowing down is going to give me this. And then I'm going to add these all up to get a total time. So 6.3 and then plus 24. And that's going to give me 36.915. And 0.915 times by 60 is going to give me that in minutes. So take off the 36, times that fraction by 60. Sorry, that's going to give me how many seconds there are. So that's 54.9 seconds. So total time is 36 minutes, 55 seconds to the nearest second. Okay, part B, it says show that her estimated time to run the half kilometre for kilometre 5 up to 20 is given as this. Okay, so the 5th kilometre would be 6 multiplied by this increase in time. So that's to the power of 1. Then the 6th kilometre, we would do that to the power of 2. And the 7th kilometre, we would then again multiply it by another 5% increase. So we can see here that this value here is the r value minus 4. So again, 2 is 6 minus 4, and 3 is 7 minus 4. So we can say, therefore, the rth kilometre is equal to 6 times 1.05 to the power of r minus 4. Can't really do more than that, really. Just that's it. It's a bit of a rubbish question, if I'm being honest. Estimate the total time in minutes and seconds she will take to complete the race. Okay. So kilometre km 1 to 4. We already know takes 6 times 4, so 24. And then after this, we've got a geometric sequence. So we need to go from, we know that let's call the first term after these 4, so the fifth term, will be 6 times 1.105, which we know is 6.3. Okay, and after she's done these 4 kilometres, then she has a total of 16 kilometres to do. With the first one that she does after the first 4 is going to be 6.3 minutes. And the ratio we know is increasing by this amount each time. So the sum up to 16 is equal to, we know the formula is this. This is given in our formula book. So we can do 6.3, 1 minus 1.05 to the power of 16 over 1 minus 1.05. Okay, so let's do that on our calculator. Okay, so typing that in gives us 149.04. So the total time is equal to the 24 at the start plus this 149.04. So I need to add on 24, which obviously gives me 173.04, and they want that in minutes and seconds, so we need to figure out how much 0.4 of a minute is. So times it by 60, 0.04, so that is 2 seconds. So it is 173 minutes and 2 seconds. Okay, I just checked the mark scheme, and in fact I was a bit sloppy in that I didn't take the full decimal expansion and multiply it through. So if I do multiply this by 60, I get 2.526 seconds, which rounds to 3 seconds. So the actual answer is 173 minutes and 3 seconds. Okay, trig equations and identities. I think this is the most common question across the EDEXCEL A level. It seems to come up every single year. You've got an identity and then you need to use that to solve an equation. So definitely one you're going to want to master. Now the important thing here is to select which side you're going to start on. Now this one is a particularly special question because you could start either way really, and in fact I might do both just for fun, and also because I just absolutely love these types of questions. Okay, let's start with this side, the left hand side. So we've got cot squared minus tan squared. Well, cot squared is cos squared x over sine squared x, and tan squared is sine squared x over cos squared x. Okay, we don't like having two separate fractions. Let's combine them by doing the old cross multiplying. So that's going to give me cos to the 4x by timesing these two, and minus sine to the 4x by timesing those two, and then we multiply the two denominators together, and that gives me sine squared x cos squared x. Okay, great. So that, the top there, is difference of two squares. When you see two even powers and a subtraction, you might be thinking difference of two squares. I mean, you might have thought that at the start actually, but that's not the way to go, because having a single cot and a single tan, it's not going to work. But this is looking promising, because if I difference of two squares this, I get the square root of cos to the 4, which is cos squared, minus the square root of sine to the 4, which is sine squared, and then I get cos squared x plus sine squared x, which we all know is equal to 1. So that's perfect. That's going to really help cancel this down nicely. What about this on the bottom? I could write that as sine x cos x all squared, because that is going to help me with my, I can see here there's a cosec 2x, which is 1 over sine 2x. So having that on the bottom is looking very much like a sine 2x using our double angle formula. Okay, so the top now cancels. So the top cancels. I mean the this one, that's just 1, so that just cancels out completely. Now the bottom, we know that sine 2x is equal to 2 sine x cos x. So therefore a half sine 2x is equal to sine x cos x, which is exactly what is inside this bracket. So this becomes, if I square this, then I get exactly what is on the denominator. And if I do square that, I get a quarter sine squared 2x. Okay, now what about this numerator? Well, we also know that cos 2x has many forms, but its most sort of natural form is cos squared minus sine squared. So that can go straight in at the top. So that's cos 2x. We're dividing by a quarter, which is the same as timesing by 4. So I can flip that 4 to the top. And on the bottom, I have sine squared 2x. Okay, great. So I can write this as 4 lots of cos 2x over a sine 2x multiplied by 1 over a sine 2x. And that way you can see the denominators times to make sine squared 2x, which is perfect, and the top is all good as well. So great, this is now equal to 4 lots of, and a cos 2x over a sine 2x is a cot 2x, and multiplied by 1 over sine 2x, which is a cosec 2x. Wowza, that was a real meaty one. I won't do right hand side to left hand side because that took ages, but I challenge you to do that. So start with the right hand side, see if you can get to the left hand side. Okay, I'll clear this and we'll do part B. Okay, part B says now hence solve for minus pi over 2 to pi over 2 for cot 2 theta cosec 2 theta. Okay, that's nice because that is exactly the same as that. What I like to do is just see what the substitution is here. The substitution is just that x has changed for theta, so we don't need to manipulate it at all. And that's equal to tan squared theta. So that means that I can use the left hand side, and I have to because it does say hence. So that left-hand side can be replaced by this left-hand side using the identity. So we get cot squared theta minus tan squared theta is equal to 2 tan squared theta. Okay, cot is the same as 1 over tan, so cot squared is the same as 1 over tan squared, and I'll just move this tan squared, I'll plus it to that side to get 3 lots of tan squared over there. Perfect. Okay, now what I'll do is I'll multiply through by tan squared. So I get tan to the 4, like that, and then I'll divide through by 3. So I'll get this. And then we'll take the fourth root. So tan theta is equal to plus minus, because whenever we take a fourth root, we get the plus minus, or whenever we take an even root, sorry, we get the plus minus. So the fourth root, like this. Okay, perfect. So let's split this up, in fact, into the positive fourth root, and over here we will write the negative fourth root. Okay, it does say give your answers to 2 decimal places. That's nice. That gives me confidence that we're not going to get exact answers, because the fourth root it will not give us an exact answer. Okay, so calculator comes out. We make sure we are in radian mode, and we do tan to the minus 1 of the fourth root, so I need to press this button here, of 1 over 3. Okay, great. So I get 0.64, well, 65 to 2 decimal places. Okay, perfect. Now, how do I find the next solution for tan? Well, we add on pi, but that's too far over the range. So let's see what would happen if I were to have taken away pi. Again, that's too far out of the range as well, so I think we're done there. Okay, so now what we need to do is tan to the minus 1 of the fourth root, the negative fourth root, sorry, of 1/3. And this gives me theta equals minus 0.65. Okay, perfect. And then let's see what happens if I add on pi to that. Will that be in the range? No, it won't. So I think we are done. Okay, next question is a differentiation year 1 question, where we're modelling. A lot of people overlook this topic because they focus so much on year 2 differentiation that they become stuck in questions like this. So it's a really important one to know how to do in case it comes up, which it does quite frequently. So a company decides to manufacture a soft drink with a capacity of 500 millilitres. The company models the can in the shape of a right circular cylinder with radius r and height h. In the model, they assume that the can can be made from a metal of negligible thickness. Okay, prove that the surface area S of the can is given by this. Okay, so we know that the volume of the can is equal to 500. And we know also the volume of a circular cylinder is pi r squared h. Okay, so can't do much else with that at the moment, but that is going to give us an expression for h in terms of r. And notice that what we have here does not contain a h. Okay, let's look at the surface area then. So how do I work out the surface area of a cylinder? Well, it's going to have 2 bases, so it's got obviously a lid and a base. So that's 2 lots of pi r squared. And it's also got the curved surface area as well. And the curved surface area, if I were to unwrap it, would look something like this. It would look like a rectangle which wraps around the cylinder. And the rectangle will have the same height as the cylinder. And the width will be the circumference of the cylinder, which is 2 pi r. Okay, so that's going to be 2 pi r multiplied by h. And this is where the first formula comes in, because I can rearrange this first formula by dividing through by pi and r squared to get h. And then I can substitute that h in over here, and this will give me 2 pi r multiplied by 500 over pi r squared. Okay, so that's 2 pi r squared, and then you can see here the pi's will cancel, one of the r's will cancel, but it will leave one on the bottom, and also 2 times 500 is 1,000, so it will be 1,000 over r as required. Perfect. Okay, it says given that r can vary, find the dimensions of a can that has minimum surface area. Okay, so we need to find the turning point of the surface area formula. So I need to do the surface area with respect to r. So if I differentiate this, again I'm just differentiating the r, pi is not a variable, it is a number. 2 times 2 is 4, pi, and then r, drop power down by 1. I could rewrite that as 1,000 r to the minus 1, and if I were to differentiate that, the negative would times by the 1,000, and then we'll drop the power down to minus 2. And we want to find the minimum, so we always find turning points, minimums or maximums, where the derivative is equal to 0. Okay, so let's try and solve this. I'm going to move that to the other side, it becomes 1,000, and r to the minus 2 is the same as over r squared. Okay, now multiply both sides by r squared, gives me r cubed over here. And then dividing through by 4 pi gives me 250 over pi. Okay, so we can find the radius by taking the cube root of 250 over pi. So we'll do that on our calculators because this is a modelling question, so we don't need an exact answer. In fact, we just need to give it to a suitable degree of accuracy. So 4.30 sounds perfect to me, and that would be centimetres, I believe. Just check the measurements again. Yes, centimetres. Okay, it's asked for the dimensions, so I'm going to need to also find the height. So we use the formula for height, which we have over here. So it'll be pi and then 4.30 squared on the bottom like that. I'll just use the answer button to keep the accuracy, so it's 500 over pi times by answer squared, so 8.60. Okay, perfect. Those are the 2 correct answers. With reference to the shape of the can, suggest a reason why the company may not choose to manufacture a can with the minimal surface area. Well, if the radius is 4.3 centimetres, that means the diameter is actually 8.6. So it's gonna look almost like a block, which so all cans are taller than they are wider. Also, if you think about that in your hand, like 8.6 centimetres is quite large. Like that would be that would just be ridiculous. So okay, looks like a differentiation by product rule. So if we have a function multiplied by another function, we can label the first one u, in this case x, and then the next one we can label as 2x plus 1 to the power 4 as v. What we do next with the product rule is we differentiate each one, so that differentiates to 1. Now this one is going to take a chain rule. Let's show you how you can do it quickly. So the 4 comes down to the front of the bracket. We keep the bracket the same, and then we drop the power down by 1. And then we multiply by the derivative of the bracket, which in this case is just 2. Okay, great. So we can tidy that up because we've got a 4 and a 2. So times those together, it gives us 8. Okay, great. So now we could do dy by dx. And we just cross them like this. So we times the u by the derivative of v, and then we add on v times the derivative of u. So the first one, x times by this one here, would give me 8x, 2x plus 1 to the power of 3. And then 1 times by v over here is just going to give me 2x plus 1 to the power of 4. Okay, but they've actually asked us to leave it in a factorised form. So this is really helpful if you're trying to find like the turning point, because when it's factorised it's really easy to solve equal to 0. But nevertheless, we can take out a 2x plus 1, and the highest power of each of these is 3 that they both share. So what have I got to times 2x plus 1 cubed by to get the first term? I've got to times it by 8x. And what have I got to times 2x plus 1 cubed to get 2x plus 1 4 to the 4? I've got to times it by another 2x plus 1. Okay, great. So now what I can do is I can write this as 8x plus 2x is 10x, and then we've also got this cheeky one here. And that is good, and we can say that n is equal to 3, a is equal to 10, and b is equal to 1. Top stuff. Okay, more differentiation year 2, and I've chosen this question because we need to differentiate a trig function and we need to use the quotient rule as well. So if I am differentiating a quotient, which essentially is a fraction, then I need to split it up into the numerator, which is u, in this case 4 sine 2x, and the denominator, which is v, which is e to the root 2x minus 1. Okay, next thing to do is to differentiate both of these with respect to x. So here, when I differentiate a trig function that has a input which is not just 1x, in this case it's 2x, I'll need to multiply by the derivative of the input. So I'll multiply by 2, and that to the 4 gives me 8. And then when I differentiate sine, that differentiates to cos, so it's cos, and the input stays the same. Okay, what happens when I differentiate an e function? Well, the input stays the same, but the derivative of the input comes out to the front. So the derivative of the root 2x is root 2. So that comes out to the front, becomes the new coefficient, and the input stays the same when I differentiate an e function. And e, it just stays the same, it differentiates to itself. Okay, so now what we need to do is we need to use the formula for dy by dx, and that is v du by dx minus u dv by dx all over v squared. So v here is e to the root 2x minus 1 times by du, which is 8 cos 2x, minus u, which is 4 sine 2x, times by dv, which is root 2 e to the root 2x minus 1. And all of that is over v squared. V squared will be e to the root 2 x minus 1 squared. And all the while it's asking us to show that the x-coordinate of the turning points is equal to this equation. So if I'm finding the turning point, I need to set the derivative equal to 0. And in this case, I only need the numerator to equal 0 in order for the whole thing to equal 0. So I'm only focused now on the numerator. Now what I'm going to do first is I'm going to look at what I can factorise out. Well, let's look at first the this term here, and then second we'll look at this term here. Now both terms have an e to the root 2 x minus 1. So I can factorise that out. Now the yellow term I would need to multiply through by 8 cos 2x minus, and then the blue term I would need to multiply by 4 sine 2x and by a root 2. So that's 4 root 2 sine 2x. And all of that needs to equal 0. Again, there is, we're finding the turning point, so that equals 0. Okay, so e to the root 2 x minus 1, that can never be 0, and e function can never equal 0. So that's not going to give us a solution. In fact, the solution is going to come out of this bracket. So when this bracket here is equal to 0. So when 8 cos 2x minus 4 root 2 sine 2x equals 0, it's going to give us our solutions. Okay, I can divide through by cos 2x, and this will give me sine 2x over cos 2x, gives me tan 2x. Lovely. And then I can just rearrange it somewhat like so. Just double checking, does that work? Yes, it does. And then finally we can divide through, so I get 8 over 4 root 2, and that is the same as 2 over root 2, which is the same as root 2. Perfect. Job done. Okay, we have an implicit differentiation question. So the first part just says find dy by dx in terms of x and y. Okay, so the first term we need to differentiate is 2y, and we're differentiating that with respect to x. But what we do is we pretend like we're differentiating it with respect to y. So y squared becomes 2y. But then whenever we differentiate with the incorrect variable, we write dy by, in this case, the variable we want to differentiate by, which is x. Okay, so 2x squared, that differentiates to 4x. 15x, that just differentiates to 15. And now another one here is in respect to y. Sorry, is a y variable. So we differentiate it with respect to y, which is going to be 10, but then we multiply it through by dy by dx. Okay, great. Now let's bring all of the terms that have a dy by dx in to the same side, like so. And then what we can do is we can factorize. So I get 2y minus 10. And then I can divide through. So I get dy by dx is equal to 4x plus 15 over 2y minus 10. Perfect. Okay, that's part A done. That's just your classic implicit differentiation. And then it says, using your answer to part A or otherwise, find the values of P and Q where the curve is not defined for values of x on that interval. Okay, so what we need to find are the vertical asymptotes. Now those vertical asymptotes happen when Not when dy by dx is equal to 0, but in fact when dx by dy is equal to 0. So we flip this over like this, take the reciprocal, and we set that equal to 0. So horizontal tangents, that happens when dy by dx equals 0, but vertical tangents happen when dx by dy equals 0. Okay, now how do I make a fraction 0? Well, it's just the top of the fraction that needs to be 0, just the numerator. So therefore this tells me quite obviously that y is equal to 5. But we're not interested in the y coordinates, we're interested in the x coordinates, because we can see here that these points cross here where the y is 5, so these points here have y coordinates 5, because those are the points which have a vertical tangent. But what we need to find is the corresponding x coordinates, so we need to sub it back into our equation. Okay, so let's sub it back into our original equation. Y squared is 5 squared, which is 25. We've got 2x squared plus 15x plus 10y, which is 10 times 5, which is 50. Okay, setting this equal to 0 gives me 2x squared plus 15x plus 25. Okay, we need to factorize this. 2x and x, and two numbers. What are the two numbers? They've got to be 10. It's got to be 5 and 5. Yeah, 5 and 5 will do it. So plus 5 and plus 5. That's perfect. That gives 25, and that gives you 15x. Perfect. Okay, so this means that either 2x plus 5 equals 0, or x plus 5 equals 0. So x here equals minus 5 over 2, and x here equals minus 5. So therefore, P is the most negative one, and Q is the least negative one. So P is minus 5, and Q is minus 5 over 2. Job done. This is an iteration question, and let's get into it. So first off, you can't see all the question just yet, but apologies for that. It says find the x coordinate of a and b. Okay, so that's the function. Okay, so we just need to set that equal to 0, don't we? So 8 minus x ln x. Where's it crossed the x-axis? Well, that's when the y is equal to 0. So this is two parts to it. It's a product. So either 8 minus x is equal to 0, or ln x is equal to 0. In this case, x would equal 8, and in this case, x would equal 1, because we know that ln of 1 is 0. So a must be the coordinate 1, 0, because obviously it's the one that comes first, and b must be the coordinate 8, 0, because it's the one that comes afterwards. Okay, great. 1 mark for all of that endeavour. Okay, so part B. Show that the x coordinate satisfies Q. Oh no, sorry, I completely misread that. Okay, we need to scroll down, that's why. Okay, so sorry. Show that the x coordinate of Q satisfies this. Oh, right, that makes much more sense. Okay, so the Q is the stationary point. And the stationary point is when the derivative is equal to 0. So we need to differentiate our function and then set it equal to 0. So the derivative function, f dash, well, this is a product, isn't it? It's got two parts to it, like I've said before. It's got this part, and then it's got this part. So we need to use the product rule. So first I'll differentiate the blue bit, and I'll get minus 1, and I'll keep the yellow bit the same. And then I will keep the blue bit the same, and I'll differentiate the yellow bit to get 1 over x. Okay, great. Let's tidy this up. This becomes minus ln x plus 8 minus x all over x. And we want that to equal 0 because we want to find out where the stationary point is, Q, right there. Okay, so we just need to rearrange this to make x the subject. That's all we need to do. Okay, so I will move ln x to the other side, becomes a positive. So I get 8 minus x over x is equal to ln x. Multiply through by x. Add x to the other side, so I get x ln x plus x. And now I can factorize out an x, so I get x and I get ln x plus 1. And then I can divide through, so I get 8 over ln x plus 1, or 1 plus ln x, same thing, and that equals x. And that's exactly what they want, so that's job done. Okay, scrolling down now. Okay, part C. It says show that the x-coordinate of Q lies between 3.5 and 3.6. So Q is the turning point. So we need to check to see if f dash of x equals 0. And if an x value satisfies that in between 3.5 and 3.6, then if I substitute in 3.5 and if I substitute in 3.6, I should see a change of sign. Because if it goes through 0, then it's going to have to go from positive to negative, or from negative to positive, or vice versa. Yeah. Okay, so we need to substitute in into the derivative function. And the derivative function is the one which we found right here. So we are subbing into this function here. Okay, I'm not going to bore you with that, I'm just going to tell you what the answers are. Okay, there we go. We've got one which is greater than 0 and one which is less than 0, as expected. And then what we say is that as f dash of x is continuous, very important that you write that, and there is a change of sign, then the x-coordinate of Q lies between 3.5 and 3.6. Right, done. Okay. Last part, it says use the iterative formula. Okay, so I need to use my calculator for this. Okay, here we go. We want to find the fifth solution. So we start by doing 3.5, press equals, and then we type in our iterative formula, but instead of writing x n, we just type answer. So the second solution, x2, will be this. Press answer again, that's x3. Press answer again, that's x4. Press answer again, that is x5. So x5 is equal to 3.534 to 4 decimal places, so 0. Fantastic. And then it says find the x-coordinate of Q accurate to 2 decimal places. Well, this is the most fun you can have in a maths exam. You just keep tapping the equals button and it's just going to tend to the root. I mean, that's overkill, but that is going to be the root that we're looking for. So to 2 decimal places, that is x is equal to 3.54. Okay, and we're done. Next question is integration, and wow, what a huge topic, loads of marks, lots of different types of integration. So I've picked this one because it's like 2 for the price of 1. You've got integration by parts and substitution. So let's get into it. Now, an integration by parts, particularly one here where it's got an x squared, I know this is going to be a double integration by parts. So the DI method is super fast at doing double integration by parts. I did this on one of my tricky questions, which you can go back and have a look. I'll link it. And but this is the method. So you draw a little table like this, and I'm going to differentiate the x squared part, always the polynomial, and I'm going to integrate the exponential one. Okay, so differentiating down, 2x, 2, 0, super easy. Integrating up, a half e to the 2x, a quarter e to the 2x, an eighth e to the 2x, super easy. Now, all we do is we just follow this curvy pattern. So this one, and then we add on this one, and then we add on this one, and then the last one, there's a 0 there, so it's going to cancel out, so we don't need to include it. So great, so my integral becomes x squared times by a half e to the 2x, that's the first green squiggle, minus 2x times by a quarter is also a half, x e to the 2x. And then the last one is 2 multiplied by an eighth is a quarter, and that's positive, and that's e to the 2x. And in super quick fashion, we have integrated that, and now what we need to do is sub in our limits of 4 and 0. Okay, so 4 squared is 16, halved is 8, and that is e to the power of 8. 4 times a half is 2, and that's e to the power of 8 as well. And here we have a quarter e to the power of 8. Okay, now 0, don't neglect it, because there is a term which when we sub in 0 will give us a value. It's not the first two because they have an x there, so they will go to 0, but it is the last one because e to the 0 is 1, and that is a quarter. Okay, simplifying this, 8 minus 2 is 6, plus a quarter is 6 and a quarter, which is 25 over 4. So it's 25 over 4 e to the 8 minus a quarter. And that is my final answer, and that is in its simplest form. So we are good. Okay, right, I'll clear some space and we'll do the next part. Okay, part 2. Now, particularly tricky this one, because most of the time they will give you the substitution, but well, how much more fun is it if they don't? Way more fun. So it's always the denominator which is the issue. So my first thought would be to set u equal to 2x minus 1. Because if we can clear that denominator and just have u squared, then yeah, hopefully it should be relatively easy to integrate. Okay, so with that being said, let's differentiate this firstly with respect to x, and that gives me 2. So that tells me that dx is equal to a half du. Hopefully that's obvious to see. Times the dx up, divide the 2 down. Okay, so that's the first part done, and then what I always do next is do my limits, just because I don't want to forget about them. We've got x and we've got u, so we've got here 21 over 2 and we've got 3. So subbing that into this u formula here, I need to double to make 21 and take away 1, so that gives me 20. And I need to double to make 6, take away 1 gives me 5. Okay, great, that's that done. And also I want to get an expression for 4x, so I can do that by adding 1 over and then doubling both sides. So I've got an expression for 4x, so I think I'm good now to substitute in. So I do my integral sign, I've got 20 as my top limit and 5 as my bottom. 4x we know is 2u plus 2. And on the bottom we just have a u squared. And then dx, don't forget to substitute that out, is a half du. Okay, great. So the half is going to cancel with the factor of 2 on the top. So that's just going to give me u plus 1 over u squared du. And this can be rewritten to get it into a form which we can integrate. I can split up the bottom now. And this gives me u over u squared plus 1 over u squared. And of course u over u squared is just 1 over u du. Perfect. Okay, we can integrate this now. So 1 over u integrates to ln u. 1 over u squared, I could write that as u squared to the minus 2. So we up the power to minus 1, divide by the new power, so we get minus 1 as the coefficient, and we're good. So it's just this. Perfect. Okay, we need to sub in 20 and we need to sub in 5. Okay, so let me do my substitution up here. So subbing in 20 gives me ln 20. Sorry, I'm not going to do it up there, I've not got enough space. Down here, ln 20 minus, this is 1 over u, so 1 over 20. And then minus ln 5 minus 1 over 5. Okay, great. So now let's subtract the lns, and when we subtract two lns, we divide them essentially. So this gives me ln of 20 over 5, and then I've got to do minus a 20th plus a fifth, which is plus 3 20ths. That was hard. Okay, so final answer looks to me like ln 4 plus 3 over 20. And then just so we could, just because it does say our constants to be found, I will say that A is the 3 over 20 and B is the 4. Lovely. Okay, here we go, differential equations. We need to express this in partial fractions. Okay, so we'll write 1 over P11 minus 2P is going to equal A over P plus B over 11 minus 2P. That is a capital P. Okay, then as always we multiply through. That will cancel the divide by P, and it will just leave me with A lots of 11 minus 2P. And the 11 minus 2P will cancel here, and that will just leave me with BP. Okay, and then we let P equal 0 in this first case, and that will give me 1 is equal to 11A. So therefore A is equal to 1 over 11. And then we let P equal, what's going to cancel that bracket? It's going to be 11 over 2. Yeah. So when P is 11 over 2, we get 1 is equal to, this bracket here will cancel. P is 11 over 2, so it's 11 over 2 B. So that means B is equal to 2 over 11. Okay, it does say that I need to actually express it in partial fractions. So technically I should write out that this is equal to a, which is 1 over 11. So I could write 1 over 11 on top like that, or I could bring the 11 down to the denominator. I think I'll just leave it like this for now, because that's just the way I've started writing it, but either would be absolutely fine. And I would get that. Okay, right, job done. Let me get some more space and we'll actually solve this bad boy. Okay, part B. We've got to solve this differential equation, and then we've also got to find the time taken for the population to double, given that it starts at 1,000. Okay, so let's just write the differential equation out, and then we will use the technique of separation of variables to solve this. So I'm going to get the first thing I'll do is I'll put the dt on the other side. So that will be the side of the dt, and the dp is on the other side, so I want all the p's over that side. And what I will do is I'll times by 22, and then I'll divide through by this p 11 minus 2p. And then that will leave me just 1 on this side. Okay, this is good because I know that the partial fractions will come into play now. Okay, so what we do next is we integrate both sides. But first I want to write this in a way which I can integrate it, which means I need to split it up using partial fractions, which we've already done. Now we know that one lot of this fraction is equal to this. So if I'm timesing by 22, it's going to cancel out these 1 over 11s quite nicely. So it will leave me with 2 lots of p, 2 over p, because the 22 will times by the 1/11th, which will leave just 2. And here, again, the 1/11th will cancel with 22, so it'll be 2, but then there's also another 2 on top, so it's 4. So it's 4 over, like that. And that's equal to the integral of 1 times by 2t. Now what I can do here is I can pull out a factor of 2, and I know that's going to help me when I integrate. So in doing so, I can convert this to a 1 and this to a 2 just by taking a 2 outside of the integral. And that's going to make it easier to integrate because now the derivative of the bottom is actually equal to the top, which means I can use my Lund rule when I integrate. So integrating this side, I'm going to get 2 lots of, again, 1 over p integrates to Lund p. Now the derivative of this one is minus 2, and up here we've got plus 2, so I'm going to have to put a minus sign here, and then that will integrate to Ln of 11 minus 2p, like so. Okay, I'll just put these modulus signs along there as well, just because that's what we're really meant to do. And that's equal to the integral of 1 with respect to t is just t, and we've got plus c as well. Okay, great. So now I can just rewrite this as a single logarithm, because when we subtract 2 logarithms, it's the same as writing it as a single logarithm with 1 divided by the other, using our log rules. So we get this, and that's equal to t plus c. Okay. I think now would be a good time to substitute in our initial conditions in order to find out c. So what catches a lot of people out is they don't read the question, and this says a thousands, so p is in thousands. So in fact, for meerkats, I'm not going to use 1,000, I'm going to use p as 1. And it says when the study began, so t is 0. So that gives me the information that t is 0, p is equal to 1. So let's sub that in. And this gives me 2 lots of Ln 1 over 11 minus 2 is 9, so 1 over 9 is equal to t is 0, so c. Okay, and I can rearrange that because 1 over 9 is the same as 9 to the power of minus 1, and then I can use my Lund rule to bring that to the front. So I can say that this is the same as 2 ln of 9 to the minus 1, which is the same as minus 2 ln of 9. Okay, great. So I need to grab some more space. Okay, this is where we got up to, and now I can rewrite it as 2 ln p over 11 minus 2p is equal to t, and we know that c is minus 2 ln 9. I can make t the subject here, so I'm going to get 2 lots of, and I can take a 2 out as well by factorising, ln of p over 11 minus 2p. That moves to the other side, so it becomes plus ln of 9. Okay, so I've just moved that 2 ln 9 over, and I've factored out a 2. Okay, so now I can say, because we've got 2 lns added together, I can rewrite that as them multiplied together. So that's ln of 9p over 11 minus 2p. Okay, now what do we want? We want to see how long it takes, so we want to find t when the population has doubled. So it started off p was 1, so we want to know what t is when p is 2. Okay, so we just sub in p is 2. So we get 2 lots of ln 9 times 2 is 18 over 11 minus 4 is 7. Okay, so bear with me, I'll do that on my calculator. Okay, and we get that's equal to 1.89 to 3 significant figures. And that will be in years, I believe, because it does say in years. Yes, it does, time taken in years. Okay, make sure you give the given units there, it's very important. Okay, now we need to show that it can be written like this. So basically, as p needs to be the subject now. So let me just grab some more space. Okay. The first thing I notice is that t is multiplied by a half. So I'm just going to divide both sides by 2 to get started. So I'll get a half t is equal to ln of 9p over 11 minus 2p. The next thing, we've got an e involved, and we need to clear that ln. So we're going to take e of both sides. And that gives me 9p over 11 minus 2p. Okay, the next thing I can see is that we've also got an e to the minus 2 a half t. So this might be a good time to do that actually, because if I take the negative power, that's just the reciprocal. So it means I could just flip over this side of the fraction, like that. Okay, lovely. Again, your negative power just means reciprocal, so just flip over the fraction. Right, now I can multiply through by 9p to clear that denominator. And then I can move all the p's to one side. Like this, because I want to make that the subject. So then I can factorise out a p. What's that? 9e to the minus a half t. Yep. And then finally I can just divide through to get p the subject. So it becomes 11 over 2 plus 9e to the minus a half t. Okay, I think we're done. It says we need to find these integers, so I might write them down just in case. So a is 11, b is 2, and c is 9. Bosh. Okay, parametric calculus. We've got parametric equations. X is equal to sine squared t, and y is equal to 2 tan t. and it says that the point P with parameter t is equal to pi over 4 lies on C. And then L is the normal to C at P, and is shown in the figure. Show that using calculus what the line is equal to. Okay, so let's start off by using the fact that t is equal to pi over 4. And that means that the x coordinate of P is going to be sine squared of pi over 4. Like that. And sine of pi over 4 is of course 1 over root 2. So I'll square that, and that will give me an x coordinate of 1/2. Okay, let's find the y coordinate now. That's 2 tan of pi over 4, which is 2 lots of 1, because tan of pi over 4 is 1. So that gives me 2. Great, so the point P is x coordinate 1/2 and y coordinate 2. Okay, now we need to find the gradient of that line. So I need to find dy by dx, the gradient function. And this is equal to dy by dt divided by dx by dt. Okay, so if I differentiate the 2 tan t, the y function with respect to t, tan differentiates to sec squared, so I'm going to get 2 lots of sec squared t. And then I need to divide that by the x differentiated. So how do I differentiate sine squared? Well, I'd write it like this. I'd use the chain rule, so the 2 would come down to the front. I'd keep the bracket the same. I'd drop the power down by 1, so that becomes sine to the power of 1. Then I'd times by the derivative of the bracket, which is cos t. Okay, perfect. So that's differentiated. And we can rewrite this by cancelling the 2's. Sec is 1 over cos, so that's the same as writing 1 over sine t, and then that cos squared, which is 1 over cos squared on top, should I say, that comes down to the bottom, times by the cos to make cos cubed t. Okay, so I think that will do the job. So let's find the gradient now at the point where t is equal to pi over 4, because that's what we want to inspect, that point. Okay, so that's 1 over sine of pi over 4 times by cos of pi over 4 cubed. Okay, so this is 1 over, and we know that sine of pi over 4 and cos of pi over 4 are both 1 over root 2. So this is in fact 1 over root 2 to the power 4, essentially. And that is the same as 1 over 4, so it's 1 over 1 over 4, so that's 4. Okay, great. So now we can find the gradient of the normal, because that is a negative reciprocal of the gradient at P. So the gradient of the normal at P is minus 1 over 4, the negative reciprocal. Okay, we've got everything we need now to find the equation of the straight line. So I'm going to use the trusty formula. So it's going to be y minus the y coordinate, which is 2. The gradient of the normal is minus a quarter. And that's going to be x minus the x coordinate, which is a half. Okay, I want it all as integers. I can see the form that I need to put it into. So I'm going to multiply through by 8. So that gives me 8y minus 16. minus a quarter x times by 8 is minus 2x. And minus a quarter times minus a half is positive an eighth. Times that by 8 is just positive 1. And then we can write this as 8y plus 2x, so move the 2x to that side and move the minus 16 to the other, becomes plus 16 to add to the 1 to give us what we so desire. Perfect. Okay, let me clear this work and then we'll move on to part B. Okay, part B. I've kept the coordinate of P there because I think we're going to need to use that. It's basically asked us to work out the shaded area. So let's split this into two sections. The first section I'll call A, and the second section is a triangle I'll call B. Okay, so in order to do A is the area underneath the curve. So we're going to use parametric integration. So the formula for parametric integration is y dx by dt dt. So I'm going to integrate between the t values of p, which is pi over 4, and the origin, which has a t value of 0. You could double check that by subbing 0 for t into the two equations, and of course you'll get 0, 0. Okay, so this is, and we have to have y here, which is 2 tan t. The derivative of x, we've already worked out what the derivative of sine squared is. It's 2 sine t cos t dt. Okay, so that's the integral I have to do. No problem. Right, let's now rewrite this. So tan t is sine over cos. So we're going to get some cancelling here, aren't we? Sine over cos multiplied by 2 sine cos is going to give me, so first off, 2 times 2 is 4. Let's get that right. Tan is sine over cos, so the two sines are going to times together to make sine squared t. And the fact that tan is divided by cos, we have a divide by cos, that's going to cancel with the times by cos. So it's just going to be 4 sine squared t dt. Okay, right, now sine squared, how do I integrate that? Well, I have to use a double angle to do that. And the double angle we use is cos 2, well, let's use cos 2t. And cos 2t is equal to 1 minus 2 sine squared t. That's the double angle for cos, and that's what we use to integrate sine squared. So rearranging this, I get 2 sine squared t is equal to 1 minus cos 2t. And in fact, I'll just move that straight in there. And what I'll do is I'll rewrite this as the integral between 4 and 0 of 2 times that, so 2 minus 2 cos 2t. That's perfect. So we're timesing it by 4, so 4 sine squared is going to be 2 minus 2 cos t. Lovely. Okay, right now we can actually integrate, and 2 integrates to 2t, and minus cos integrates to minus sine, so there's still the minus sign there. The input is 2t, so we divide by the derivative of the input, so we divide by 2, and that's going to cancel out the 2 in front of the cos 2t, so it's just going to be sine 2t. Lovely. Okay. Now let's substitute in pi over 4. So pi over 4 times by 2 is pi over 2. Minus pi over 4 times by 2 is pi over 2. Sine of pi over 2 is 1. So minus 1. And then subtract the lower bound is 0, and both of those will be 0, so that's just 0, because, yeah, okay, fine. So that gives me pi over 2 minus 1. Lovely. Okay, that's the area of A, so we're not quite done yet. We still need to find the area of B. So let's just remind ourselves that P, the x-coordinate for P is 1/2, and we need to find this coordinate here. And also the y-coordinate of P is 2, so the height of the triangle is 2, and we just need to find the base of the triangle. So what I'll need to do is I'll need to look at this this formula for the normal and see where it crosses the x-axis. So it crosses the x-axis when y is 0, so that gives us this, which means that x is equal to 17 over 2. Okay, so that's 17 over 2 there. Okay, so what's the distance of the base? What is the base? Well, it's the gap between 1/2 and 17 over 2. So that's 16 over 2, so that's 8. So the base of that triangle is 8, and the height is 2, because it goes up to 2 in the y-axis. So B is equal to 1/2 base times by height. So that's equal to 8. So the total area S is obviously equal to A plus B, which is equal to pi over 2 minus 1 plus 8. And that's equal to pi over 2 plus 7. And we're done. What B's question? Hope you enjoyed that. Hope you enjoyed this whole paper in general. And if you did, please do drop a like and subscribe. And also look out for predicted paper 2, because that will be coming out in between paper 1 and paper 2. And that's where we can get the real predictions, because we will know what will be in paper 1, because we would have sat it. Fingers crossed you do well. I really hope you do. All the best. Bye for now.